So good afternoon. My name is William C., and I'm going to go ahead and give you a brief overview of my information security and networking presentation that I give to all of my cybersecurity students. This is some of the information that I've developed over years, both in tutoring and also from practical experience. These are the topics that the reference guide it will address. You notice that we have some of the information is from the ISO International Standards Organization group. Some of it's from NIST, which is the National Institute of Standards and Technology in the United States. The two primarily that we use are 27001 for ISO and 853 for NIST. There's a lot of risk management that goes along with this, but I also touch upon basics that you will be able to see whether you're taking your A plus, Security Plus, or Network Plus certifications from the CompTIA, or if you're going down the ISC squared path and want to go after your CISSP or the most relevant cert that they have today, or if you want to get into cybersecurity information system auditing through the ISACA group, I also have tutored successfully students in that. At the moment, you'll notice that we go into cryptography, the various domains. When I received my CISSP, there were 10 domains. Now there are 8. We discuss cloud services, the Amazon Web Service, the Google Cloud, and also Azure. I talk about DICAP and FedRAMP, which are the federal regulations that are for the information system security. FedRAMP is for cloud-based, and DICAP is what covers the rest. And we get into other aspects of cybersecurity, such as asset identification, the risk management frameworks. Prior to 2015, there were, as I said, 10 domains in the CISSP, which was access control, telecommunications and network security, information security governance and risk management, software development security, cryptography, security architecture and design, operational security, continuity of business and recovery planning after disasters, legal regulation, investigation compliance, and physical environment security. That has now been reduced to 8 domains: security and risk management, asset security, security architecture and engineering, communication and network security, identity and access management, security assessment and testing, security operations, and security development security, software development security. Um, Again, in NIST 853, they use control families as opposed to just straight controls like they do in the ISO standard. These control families are listed here: access control. I'm not going to read all of them, but they're available, and we will cover these during tutoring. And I go into depth on each one of these particulars. The ones that are standing out and most people run into problems with are the IAM, identification and authentication management, the cryptography piece, and the controls around that, configuration management, and also incident response and risk assessment. And those are the ones that we will spend particular attention. The NIST 853 goes ahead and talks about the way the system trustworthiness model is set up. There's trustworthiness is based off of the risk response to the variety of threats, either hostile cyber attacks, natural disaster, structural failure, and human error. The thing that's interesting about all cybersecurity is it is approached from a risk management perspective, and you can tell that the it's not just a hacker, for instance, that's going to be a threat to the organization. You have to take into account whether or not there are natural or other disasters that can occur, and then because of that, you have to have contingency planning for business continuity and disaster recovery. We see a lot of that happening in today's world based on changes and political uh, posturing. DICAP is the Department of Defense DoD Information Assurance Certification and Accreditation process, which is what they will certify or accredit any of the particular information systems that are necessary to be used by the government or any of its federal organizations. The main goal is to ensure that all the DoD information systems maintain an acceptable level of information assurance and information security risk management throughout the life of the system. And this is directly out of the NIST 853 that talks about that. Here again, we have FISMA, which is what happened in 2014, where they updated the federal security practices by codifying the Department of Homeland Security and requiring OMB to amend and revise the OMB 130 to eliminate inefficient and wasteful reporting. A lot of this is pretty dry, but we'll get into more of this during any sessions. And I will specifically use the information. If you have a online exam prep, we will definitely go through that. You will understand all of these concepts by the time we're finished. In the cybersecurity framework from NIST, we are looking at identify, protect, detect, respond, and recover. And these are the subcategories of each of those under identifies and protects and detect, respond, and recover. Um, this is let's get past this. FIPS 200 and SB 853. So FIPS Publication 200 is the minimum security requirements for federal information and information systems. And it's a mandatory federal standard developed in response to the FISMA ruling of 2014. and it's the security control baseline. So basically, when you have a information system that you want to secure, you have to have an understanding of what the possible threats and vulnerabilities are, what those exploitation avenues are, and how to mitigate those. And this goes into creating a risk environment analysis of your system, and then we go ahead and quantify that. These are some of the examples of controls for privacy, specifically around HIPAA, and the way that the control family is in this is over here in the authority and purpose would be AP, accountability, audit, risk management, AR, data quality, integrity, DI, data minimization, retention, DM. And this is how FedRAMP works. You cannot actually, as a enterprise, get a FedRAMP certification. You can utilize cloud services that have been FedRAMP certified, and it's noticeably the Google Cloud, the Microsoft the Azure, and the AWS cloud services that are FedRAMP, given an authority to operate, an ATO, authority to operate. And Alibaba Cloud, for instance, does not have such a thing. So this is important if you're getting into any kind of organization that's going to be touching the federal government at all. Some educational facilities, some training facilities, they have to be certified to FedRAMP standards because otherwise the federal government will not use them. Let's see. Getting through this, we talk about business drivers. We talk about the cloud service leaders if you're going to get into the Gartner quadrants about this type of analysis. And you can see, again, Amazon Web Services is way up here in terms of the performance and maturity versus Microsoft versus Google, Alibaba, Oracle, IBM down here. What's the difference between 27002, 27001, and ISO? Now, in the European environment, they use the ISO as opposed to NIST. Organizations in the United States that want to do business in Europe typically will adopt ISO 27001. That's the framework standard that the information system is secured to. The guide for that is 27002. It's similar to the NIST 853 control families, and it breaks it out independently here. And then the only way you can get certified to 27001, which you can get certified to, is through independently audited certification. You cannot get certified to any of the NIST standards at this point. And I'm going to jump down through here because most of that we're going to be recovering. Key concepts here in ISO is a statement of applicability, which controls the scope, the roles and responsibilities of the stakeholders, the records and documentation management per the AIM lifecycle, incident response. This is cradle to grave. Let me go back. This is cradle to grave of documentation and record management. Incident response, communications, business continuity, disaster recovery, infosec training, supply chain management, and change management. The number one key concept here is the ISMS must align with the goals and business objectives of the organization. You will see that in every certification, from CISA to CISSP to any of the ISO standards that you, as a practitioner and a cybersecurity expert, will find that business organizations' goals and the strategic objectives have to align with the ISMS, that's an information system management system, uh, goals. And the primary goal is continuous improvement of that ISMS by creating and enforcing an information security policy, the procedures that go along with that, how to implement them, and that will provide detection and response. To that end, a management champion takes ownership, and management provides commitment to the ISMS by they produce a charter document that is signed off and mandates the direction that the ISMS will follow, and the scope parameters are defined within that, and also whether there's a statement of applicability as to how that's being enacted. And the key concepts here is you'll have an audit, a self-audit or internal audit, a certification audit, an extension audit, or refresh audit. All of these are done. The only one that really is not be able to be done in-house is a certification audits. These self-audits and internal audits are absolutely able to be done in-house. Certification audits have to be done by a third party. Again, ISO you can certify to, you cannot certify to the other NIST standard. I also go into the CEH, Certified Ethical Hacker. We discuss attack types, whether they're signature-based, behavior-based, how to defend against this. I also get into subnetting. We talk about networking. If you're going to go for the Network Plus, I can do this one. We talk about how to subnet things. We talk about how the subnet network is broken up into the subnets and the hosts, and also talk about the CIDR or CIDR notation over here. This shows the ranges of what the network IDs, broadcast ID, and the host range in between. Network ID is the one that the ID of the actual network itself, the IP address of this starts at 172.16.0.0 and extends to 172.16.63.255. In between there, the dot 0.1, 0.1 and 63.254 are all the host range of where these hosts can live. And you'll notice that in this particular case, because we have four subnets, the 172.16.0.0 through the 172.16.192.0, that you have a potential of 16,382 devices that you can run on that particular network. And this is how it breaks out in terms of if you were to go to a subnet that had 10,000, I'm sorry, 1,024 here. And this shows you the IP address ranges. Again, we get into that in more detail. This is how it's broken up in terms of binary. So the top number here, 192, 168, 355 is this number, and then 255, 255.0 is that number right here, and then this gives you the difference. Then we're talking about TCP/IP. We'll get into the various way that the protocols are set up and what the various layers are for the OSI model. We'll talk about the way that TCP/IP was architected and what each layer is about, what it does. We talk about address resolution protocol. This is very important in that it's an IP address and MAC address pairing that identifies each device on the network uniquely. And then we'll also, as I said, get into OSI model. I have cute little uh, mnemonics such as please do not touch Steve's pet alligator to tell you the order of these particular layers. I also have other information about what lives at what layer, applications on the application layer, operating systems on presentation, servers, firewalls, routers, the LAN, the PC, all these various layers. We get into detail. Again, where specific devices actually are in those layers. And then we'll talk also about encapsulation of the data. How does a TCP/IP packet work? Deep packet inspection, how antiviral and anti-malware programs work to do signature identification using deep packet inspection. This is next gen firewall information. We talk about the wiring order for RJ45 and Cat5, Cat6, Cat7 cables. Here's a physical representation of what that looks like. Then we get into cryptographic information. How does cryptography work? You talk about hashes. You talk about the different types of hashes. You talk about digests. We talk about all the different ways that this cryptographic information comes together to protect your data. And then finally, we get into the way that you have asymmetric and symmetric encryption here. And we discussed that. Remember, symmetric, same key. S as in symmetric, S as in same uses one key for both encryption and decryption. Asymmetric is the other one. It uses a public key and a private key. As long as you can remember symmetric uses the same key, you know the other one uses two keys. And this is how it's represented here. You see that there's a cryptography. You have a symmetric key encryption here, and you have public key encryption and hashing. Hashing is used for uh, non-repudiation and making sure that the data has not been compromised. And this presentation that I'm showing you here, I give again, like I said, to all of my cybersecurity students. We will cover this. This is a free reference for your purposes. Here's asymmetric encryption example. There's a public key and a private key. The public key encrypts this plain text message to give it ciphertext, and then the private key decrypts it over here and gives back the plain text. In symmetric, what you have is a plain text that goes into a shared key situation where an algorithm encrypts it, creates a ciphertext, and then the ciphertext is then transmitted, and the same key decrypts it for the plain text on the receiving end. Um, and that's pretty much it for this particular presentation. And if we have any other questions about it, I will be more than happy to answer those. I typically charge more than $48 per hour, which is my base rate, because this particular information is complicated and therefore the rate is higher, just to let you know. Thank you very much.